Hello and welcome to a Minitab Express version of Let's Do a Case Study and Fun Times and Statistics. So what I'm going to do today is take you through how to do some two-sample mean testing. As you can see on the left, I have the data for this example, which can be found on your lovely Blackboard site right above this video. Ooh. As you can see, I have on my left the data for this video, which can be found just above the video by the title. So I've got it already uploaded into Minitab Express. And then over here on the right, I have the document we're going to take our notes in that describes the data. And if you want, you can read this description. You probably should before we begin, but I'm going to get right into how do we do this. The first thing I'm going to check is my assumptions. Now, ideally, you should be checking all your assumptions. For this part, I'm just checking the nearly normal condition by doing a histogram separated into groups, just in case you haven't seen that done before in Minitab. So little note to self. I'm not checking the other two assumptions, but you really should be checking independence. Still need to check independence. And that the sample is less than 10% of the population. Woohoo! Okay. Now, let's make ourselves some histograms. So if you've never done this before, here's how you make a histogram using Minitab Express. Everything we need for making any type of graph is found in graphs. I hope that isn't too surprising. And since we're interested in doing a histogram, we're going to click on the histogram button, and it's going to give you some options. You can do a simple one with this, but it's complicated to do with Minitab Express, so we're going to do the with groups option. All right, and it's going to ask me for, hey, what do you want as your y variable? We're going to throw our quantitative variable in there. And for our group, we're going to be placing our categorical variable that'll separate it into two groups. So we'll have two groups, one for offer and one for no offer. And as always, the graph is super hard to see. So we're going to paste it into here so you can see it. All right. So there we go. There's what she looks like, or he, or I don't know why I gave this a gender. And what we're looking for here is, does this look kind of normal? Does it have any, do they both have conditions that make them look like the normal distribution? And they both are symmetric or fairly symmetric. I mean, the offer one, the offer graph, sorry, is a little bit more skewed than the no offer graph, but they're both symmetric enough to where this is okay. And both are fairly unimodal. I'm just calling them unimodal. I'm getting lazy. So that's enough for this to look nearly normal. And that's all we're really looking for. It just has to have enough characteristics of the normal distribution to look okay. And this satisfies that condition pretty readily. So we're good to go for that. Okay. Next up, we're going to state our null and alternative hypothesis, perform the test, and then make ourselves some conclusions. So for my null, let's see, set up. So I think that the mean or average for the offer group is going to be the same as the mean or average for the no offer group. So what I'm saying here is I think that on average the people who receive the offer have, you know, an average spending or spend lift if you want to think about it that way, that's the same as the no offer group. So on average they behave the same way. Woohoo. That's all this is saying. Now, if you go back and read through the description here, you'll notice that so we think there's no difference between the groups. That's what we're going to say, is that on average, I think offer or no offer, we think they're different. So what you're saying here is that you just think they might not be the same. You're not saying one's bigger than the other. You don't know. It's like, hey, I think there's some difference between them. Not really sure what it is, though. Okay, so next up, we're going to perform the test. Come on. Oh, why is this not working? There we go. So to perform the test, like almost everything sort of statistical found in Minitab Express, it's under the statistics button. And then we're gonna go, oh no, I'm gonna have to move this a little bit, sorry. Here we go. So we're going to go to the to sample option, and then we're going to go to the to sample T. Notice there's some other ones inside of here. We're not so interested in those. There is the to proportion test, which you can do instead of, well, it's kind of like the chi-square, but only when you have two proportions. You'll see examples of that in, why am I umming so much? Case 4, if you're interested in that. So I want the to sample test. Woohoo! Which is fairly simple. In Minitab 17, the first thing we have to tell it is, well, we're on the right setting, so both samples are in one column. That means that I've got my quantitative data down here. I'm going to move this over a little bit. In one column, the spend left column, and it's being sorted into two groups by the group column of offer, no offer. So spend lift and group. And then we want to check our options, because you should always check your options. So it's saying the difference is nothing, and there's my confidence level. And the other thing to note is it tells you up here in your options how it's doing this test. So it's like no offer mean minus offer mean. So notice this is ordered a little bit differently than what I did for my null and alternative hypothesis. They're the same. It's looking at the difference and saying the difference is 0 or not 0. And here we go. We're good to go. And I'm going to copy my diff. Where is it? So this outputs a lot of stuff, by the way. It tells you information about the method, how it's doing that. Mean 1 is no offer, mean 2 is offer. It gives you the standard deviations, the means. It also gives you the standard error for the mean, so this is the sample mean, or the sampling distribution mean. And it gives you a confidence interval. It's kind of a nice confidence interval. All right, and then it tells you null alternative. Here's the part we need for the test. Copy that, and I'm going to paste it into here. And it pastes as an image. Oh, it pasted that kind of weird. Either way. So what this is also giving us that's kind of nice is it gives you the degrees of freedom. So remember how that was a gnarly, terrible formula? It's much simpler when just using Minitab to do it for you, which is kind of nice. So I'm hoping you notice that we have a very, very small p-value. So I think we know what we're going to be concluding here. Hey, I think there appears to be a difference. So you have to be a little bit careful in how you state that with your conclusion, because you got to make sure that you mention the thing you're measuring is means. So here we go. The evidence, well, I'm going to say there is strong evidence that there is a difference in average spending. Sorry for the weird pause. Okay, so there's a difference in average spending depending, for those that received the offer when compared to those who did not. I did write this a little bit differently than the Minitab 17 one, so it's not a bad idea to watch that video too. Just some different ways to phrase this. And since my p-value is so small, I'm going to report it because also we're good scientists, so we should be reporting p-value. The p-value of 0.0013. Pretty small. Good evidence. All right, so for the second part of this little example video of case study stuff, I'm going to do a pooled test. So there isn't a huge difference between these two tests, and I really want you to see that so that you can compare them and see what's going on. So we're going to do the same null and alternative hypothesis so we can compare them a little bit better, because I'm still doing the same test. I'm just, same question, same claim that I'm trying to, sorry, I couldn't think of the word I was looking for. I'm still testing the same claim. It's just a matter of, oh, well, what test am I using to do this? So I'm going to perform the test with a pooled test. So it's very easy to do this. It's a very slight change in our options when we're doing our to sample test. So we're going to go up to sample, and choose the T again. And we're still doing spend lift with group. And then we're going to go hit options. Sorry, spend lift group, sample, sample. And then one change right here. Oh, look, there's a little box. Assume equal variances. Hey, that's the assumption that's needed to do the pooled sampled two-sample t-test. That's the one I want to check. So it's just a check of a box. And I'm not kidding. That's the only difference to make it pool. It's pretty easy to get. It's also pretty easy to miss. We're going to go ahead and hit OK. So you look at this. Oh, this doesn't look any different. Oh, equal variance is assumed for this analysis. Got to be careful. Okay, so same report, some descriptive stuff. Oh, my confidence interval looks a little bit different, doesn't it? Oh no, it's a 95 and I meant to do a 97. I'm gonna have to do this again. Okay, let me just finish this and then I'll go back and do it again. Okay, there's our p-value. Oh, look, it came out the same, and there's our degrees of freedom. It's slightly different because how the degrees of freedom is calculated now is it takes the two groups and just subtracts one from each of them and adds them together. So it's doing degrees of freedom plus degrees of freedom to get the overall group degrees of freedom. And that's the only difference. Our p-value even came out the same. And this is usually the case. Usually the difference between the pooled and unpooled is so little it's not noticeable. The other reason why it's not so noticeable here is my standard deviations are so close together that it's not calculable. You can't notice it when you calculate it. Words. Okay, so perform the test. Check. Let's put that sucker in there. And one thing that's noticeable about this, I'm hoping for all of you, is that it doesn't change my conclusion. My p-value came out the same, and most times this will be the case. When we do, if you accidentally pool, it won't be a big deal. Okay, I'm gonna have to do this again to get the 97%er. I should have been clever and did the 97%er. I just learned the lesson of you should always read the problem before going through all of it. Boo on me. So we go back to our two sample. Still spend lift, still group. Still assuming equal variance. I want 97, and I always forget that this won't do 97. Oh, shuckly doodles. So let's hit cancel. So let's see, my degrees of freedom is 98. So I'm going to need to do some calculating. So I'm going to go to distribution plot, display probability, and I don't want normal, I want the t. My degrees of freedom is 998. And let's see, this is a equal tails, and it's 97, so in each tail there's going to be 3%. This is how you get a T, by the way, on Minitab in order to make a confidence interval, which is exactly what I'm up to. I'm going to hit OK, and what's my value? 2.1713. Okay, so, I got to take my mean difference and add and subtract that times a bunch of stuff. So, hold on, I gotta write this all out. I had to add and subtract my t, which is 2.17320 times my pooled standard deviation divided by the square root of the sample size. So I gotta go back to this. Where's my pooled value? Oh. It doesn't actually report it to you. Well, poop. This is about to get super hard. Okay. So my estimate for the difference is, oh, it's right there. I'm so blind. Pooled standard deviation. Negative 120. This is real-time problem solving right here. Because you're like, oh my gosh, how am I going to do this? It didn't actually give me 97. Here's how you do it. You come up with a t-value associated with 97. You grab the difference, and then you add and subtract the pooled standard deviation divided by the square root of the sample size. And here's where you have to be a little careful. So I need the pooled standard deviation 589 divided by, I'm going to write squirt. This is the mathematical symbology on how you do a square root. S-Q-U-R-T. That's fun. Divided by the square root of, what's my sample size? So my degrees of freedom is 998, so this has got to be 1,000. Because each of my groups I'm subtracting one. Okay, so you'll calculate this. That'll give you the 97%er. I'm going to pause and pull out my calculator to do this. Okay, and that is my result. So the next thing I need to do is I need to describe this. So a couple things you notice, it's completely negative, And it's not got a 0 in it, well, because it's completely negative. So that means when you're looking at doing this comparison, mean 1 minus mean 2, or no offer minus offer, offer is always larger because this is negative. So we're going to use that in our description. Oh, that's terrible. Make it purple, make it bigger, make it legible. We are 97% confident that where is it? Oh, it's literally right above here. The average spending for the offer group is between $160.48 and $79.52 above the no offer group. And this is kind of nice because it reflects our conclusion and gives us some more detail than the previous one. So we already knew that they were different, but this specifically tells you, oh, not only are they different, but the offer group is goes significantly more. So the offer seems to be making some effect. People are spending more who receive the offer. This is a good thing. So there you go. Okay. Alrighty. Let's do the paired test. So this information is just summary information to create a difference test. I need to come up with my null and my alternative hypothesis. I'm hating myself a little right now for how I speak. Okay, less self-deprecation. Okay. So if you read through this, it's about the sweetness of cola and whether or not after a taste test their opinions change. So this is clearly a before and after. It's great opportunity to try to do a difference test with pairing. So this is different than the examples you saw in the lesson area for examples because you're given summary information, not raw data. So we need to be a little bit more careful in how we enter this in. So my hypotheses are going to be that my mean difference is 0. So I think that there is no difference between them. They're the same. So my measurements were the same post-taste test. And my null is that I think there is a difference. So I think that it's not equal to 0. So I think there is some difference there. Woohoo! So let's perform the test. So we're going to go up to the to sample option and we're going to choose paired. And it's going to be like, hey, you got some data? Each sample in its column. Nope. I have summarized data. Yay! So the first thing it asked me for is my sample size, which is 10. And then the next thing it asked me for is what's my sample mean, and that's 1.02. Oops. And then my sample standard deviation, 1.196. And then, as always, we should check our options to make sure those are set up to match what our test is. All right, sample difference is 0, 95%er, and not equal to, just like we want. Perfect. Now, couple things. Notice that it states, oh, mean difference is calculated by doing the mean of the samples difference. So it's like I do the subtraction of the samples and then I do the mean. On all of our previous tests, I'm hoping you noticed that this said mean of sample 1 minus mean of sample 2. So am I doing the difference of means or the mean of differences? And that's the difference between a paired test and an unpaired test, or the pooled and unpooled tests. So there's the big difference there. Let's go ahead and hit OK and look at our results. Woohoo! So it gives you a couple different things. It gives you your standard deviation. It gives your standard error for the mean. So again, this is the sampling distribution standard deviation. There's our confidence interval, should we need it. And it tells you how it's calculating the test. And then if you look down below, it gives you your T and your P, which I'm going to copy into here. And then I need to state my conclusion. So what do I think is really happening here? Well, super small p. So this is definitely a little bit questionable for a couple different reasons. So if we were doing 5%, this p-value is less than 5%, and then we would be rejecting and saying, I think there is a difference. The difference between these two values is clearly not 0. There seems to be something that this tasting is doing to the judge's sweetness measurements. And then you might look at this and be like, well, no, that's not small enough. I'm not okay with 5%. I need at least 1%. In which case, this p-value is actually bigger than it. And so you would be failing to reject and saying, oh, there is no difference. So the tasting did nothing to change the judge's sweetness ratings on the cola. So I'm going to go ahead and go with 5% since that's the usual standard. So I'm going to say, hey, there is, let's go with the evidence suggests, I was going to say strong, but it's not that strong, that the sweetness ratings of the judges is on average, gotta mention that mean in there somewhere, different after the tasting. All right, with a p-value of 0.0245. So, that's spaced weird. As you look at this, I'm hoping you realize that, oh, this is why it's so important to report your p-value, because if you were not in the 5% group, you wouldn't be like, nah, man, this is totally not what I was saying. This is not pointed towards rejection land. This isn't small enough to be significant. So keep that in mind. Have a good day.